Hi there, welcome to yet another edition of the Special Maths. Um, so we'll be looking at the National Maths Olympiad, second round as for Nigeria, senior category. So we're looking at problem 3. Okay, so the problem goes like this. At the board, fractions are written in their lowest form. So we start with two fractions at random. So let's say A and B. A, B, and say C over D. Okay. So perform the operation whereby we replace one of these fractions, let's say C over D, by another fraction as equal to A plus C over B plus D. That's the sum of numerator for the new numerator and sum of denominators for the new denominator. Okay. Now why we write this fraction on the board, it doesn't have to appear this way. So it's going to be some x over y, where x over y is like a reduced form of it. So what do we mean? So just a quick example by giving the problem. So when we add, we have 15 over 7 and 10 over 3. When we add the numerators, that gives 25, and the denominator gives 10. See that even though we have this fraction already, we reduce this further by cancelling 5 from numerator and denominator. So what we actually have there, the lowest form, is 5. So x over y is what I'll be representing by that lowest form, meaning that we must have cancelled something. So what we cancelled, I'll call it t. So next, a plus c is tx, and a plus d is ty. And then the GCD of x and y is also 1. This is to ensure that it's in the lowest form. Okay, so we go like this, and we just keep repeating this process. So to answer this problem, there are different ways you can go about getting insights on how to approach this. One way is you can look this up. So this operation here to get A plus C over D, operation is called the medians. Okay, so you can look this up and be related to some array sequence. So it kind of has a relationship with that. So that may give you some useful insights. Another thing you could do is to attempt, like, just try repeating this process over and over. Eventually, you see that every new term we get can be expressed in this form. So I'm not doing that. Just for those I'm interested with, just to have an idea of where we are coming from. So it has this form, right? It's not as simple as just simply adding, like, to get the next one. It's not as simple as simply adding a plus this. So it's not as simple as this. Okay, that's because rather than using a plus c, you'll be using x. So this is going to be like the new term coming in. Just that by manipulating, let's say, multiplying numerator and denominator by t, you will end up getting things of this form. So generally, we could always express things of this form, and once we can do that, we can always ensure that n are combined. So the next thing you might want to going in that direction is what could be possible cancellations you could have. So if you look at a common prime factor, so if you have some p, so it's possible to show that divides AD and BC, where so long as you make sure that m and n are prime. So this can be shown, and this is what's going to lead to the next stuff I'm going to do. So I'm going to go straight into the solution now. Okay. All right. So let's say delta n AD minus BC, where and on the board after n minutes. So of course this fraction is their lowest form. Okay, so we're going to so this is quite an important structure. So we're going to exploit this. So now want to see how the next term of this sequence is going to relate back to this. So we want to consider delta n plus 1. So to get n plus 1, we do need to know what the new fractions to be. So we have two options. So this or this. So where x over y is, as I mentioned earlier. Okay. So now in this case, in the first instance, this gives that delta n plus 1 particularly would be ay minus bx, while the second instance gives dx minus cy, absolute value. So we could just kind of consider something slightly different from this. So recall that a plus c is t times x, and b plus d is t times y, right? So one thing to observe, very key observation, is that if we replace d and c by b plus d and a plus c, we end up getting the same expression. So we just write that b plus d minus a plus c b, okay, or b a plus c, whatever. Okay. So if we expand this, you see that we get the same stuff, and the same we can take it the other way around. So we could replace a and b by a plus c and b plus d. Okay, so that gives a plus c d minus b plus d c. So for the first one, a b we have, so this is kind of like an invariant for this problem. Only we are not going with plus c itself, so going something a bit different. We prefer to work with x and y for delta n plus 1. So just substitute that in the tx. On the other hand, we have txt and tyc. So from this relationship between delta n plus 1 and delta n, and the idea is that irrespective of whichever case we pick, so that case 1 or case 2, we are going to end up getting exactly the same stuff. So this is delta n is equal to t times ay minus bx, which is going to be t delta n plus 1 if we have the first case. Okay, or for the second case, we'll go with the second expression. So we could factor out t from here and get dx minus dy, which is just the same stuff. So this means it doesn't really matter if second case. It doesn't really matter which of the cases we have the same stuff. So what we have now are integers. These are always integers combination. they are integers, and they are also they're also positive. You can check that it's definitely not 0. So this is what we have total. So what's t now? So that means t is quite important. So let's backtrack a bit. So t here is what we must have cancelled out, right? So where t is the cancellation. Okay. So this means that we could keep track of like what we cancel out. So we start with some delta n. Then what we are canceling, what we cancel out have to be a factor of that number. Then we have something left. Then continue with this one and probably cancel something out again. So if we continue canceling out, eventually we run out of factors for our delta n, and that's the we're going to be going. So the idea is that say let Tn be the cancellation after n minutes. Okay, so what we're just going to get is that for the when we move from the nth minute to the n plus 1 minute, we end up getting something that looks like this. Okay, and if we start initially with that's before the first minute, so that'll be delta 0. So this is the initial the term of the sequence. Then we can write express things the following. So it's kind of an inductive expression. Okay. So, and all these are integers. So we have that at very least t1, t2, t3, up to any n multiplied this number. So becomes apparent that eventually this so eventually Tn is equal to 1. So to prove this properly is we could just use prediction. So it's not then they are infinitely let's say I1, C2, C3. So definitely many terms that will not be 1. So greater than 1. And the fact is that these are all positive integers. So the fact that integers mean that they all have to at least start from 2. So if we take like products of those numbers up to some k, and greater than the raised power k. So if we consider the product starting from 1 up to last number, then definitely has to be at least this. These parties could be 1 or bigger. So this is whatever which is equal to 0. So this is greater than raised power k, and that delta 0 must be greater or equal to k. So we cannot have infinite such k's. So these are bounded. So we have a contradiction. But we have to big factors. To get the point, we've kind of exhausted all the factors from F naught. Once we've done that, don't get any new cancellations. So the point here is that once we have Tn is 1, then basically there was no cancellation. So x was negative. So, right. So I hope that was